So today we shall discuss the greatest integer function for a real number x. This notation, into square brackets we write x, called as the greatest integer function, or another name for it is the integral part of the real number x, or it is also called the floor function. And the meaning is, it is the largest integer less than equal to the real number x, less than equal to the real number x. So if you take 2.4, the integral part or the greatest integer less than equal to this is 2. If I take minus 2.4, this is a negative real number, then there are two integers which are near to this real number. They are minus 2 and minus 3. But minus 3 is less than or equal to this. So this is minus 3. If I take an integer, then the greatest integer function has the value 2. We also denote it by this floor function. We write this below, not above, because it is a number which is less than or equal to the given real number. These are all less than or equal to the given real number. There is a corresponding function which is called ceiling function. That also is sometimes considered. So ceiling function is denoted like this. This is ceiling function. For example, what is ceiling function of 2.4? It is the number next to this integer, next to this. So is going to be 3. It is the smallest integer which is bigger than or equal to 2.4, or minus 2.4. This is minus 2, ceiling function. And if I have an integer, ceiling function is that integer. So this is the difference between the ceiling function and the floor function or the greatest integer function. We will see some properties of this greatest integer function, that this greatest integer function of x is an integer, and if x is the given real number, then integral part of x is less than or equal to this, and this is less than or equal to integral part of x plus 1. To see this, if you take any real number, you can write it as integral part of x plus r, where this r is a real number between 0 and 1. 0 less than or equal to r less than 1. Any real number x real, you can write as integral part of x plus r. This is the basic thing. From that, it follows that this integral part is less than or equal to x, and if I consider integral part of x plus 1, then that is bigger than this. So this is actually less than integral part of x plus 1. So in fact here we can have inequality that x is strictly less than integral part of x plus 1, and this can be equal to this. Integral part of x can be equal to x, especially when x is an integer. X itself is an integer, then these two are equal. But here we have strict inequality. So this follows from, so this is the basic thing. Okay. So r is less than 1, so this is less than integral part of x plus 1. That's why we get this. So from this you can immediately get this result. That is because you subtract 1 from this, both sides, x minus 1 less than integral part of x, so you get this. Okay. Just from this thing, this part, you get this inequality. And this thing is just written over here, integral part of x less than or equal to x. Okay, so from this, so here only the real number x is in between and integral part is written on both sides. Here integral part is written in the center and it is compared with the real number x. What is the lower bound, what is the upper bound for this in terms of the real number x. And again this is written in a different manner. See, again use this. Use this x minus integral part of x, that is bigger equal 0. That's written here. And similarly, x minus integral part of x is less than 1. So from this you get all these inequalities. Now this is another way of looking at the integral part of x. It is the greatest integer less than equal to x. So you can write it in a different manner, that it is summation 1 less than or equal to I is an integer varying from 1 to x. So all integers up to x are taken care of. That many times you add 1 and that is the integral part of x, if x is bigger equal 0. X plus m integral part is equal to integral part of x plus m if m is an integer. So to see this you just write, so to see this 3, write x equal to integral part of x plus r, where 0 less than equal to r less than 1, and then add m to it. So x plus m is equal to integral part of x plus m plus r. This is an integer and this is a number between 0 and 1, 0 less than equal to r less than 1. So the integral part of x plus m will be equal to this number, which is integral part of x plus m. That is what this third property says. And this is useful in calculating the integral parts in problems, because this integer we can directly take outside the integral part sign. So here this you can see again by writing x and y in terms of integral part. So if you want to prove this, proof of 4, x and y are real numbers, so write x equal to integral part of x plus r and write y as integral part of x plus r dash, integral part of y plus r dash. Now r and r dash, what are they? They are real numbers between 0 and 1. So if you add these, we get x plus y is equal to integral part of x plus integral part of y plus r dash. And what is r plus r dash? R plus r dash is a quantity which is between 0 and 2. 0 less than or equal to r plus r dash, which is less than 2. So, in any case, integral part of x plus integral part of y is less than or equal to x plus y, but the possibilities for this x plus y integral part are, what are the possibilities? Either, see, the r plus r dash can be less than 1 is a possibility. If r plus r dash is less than 1, then integral part of this is equal to integral part of x plus integral part of y. Whereas if r plus r dash is bigger or equal 1, then the integral part of x plus y is integral part of x plus integral part of y plus 1. So these are two possibilities for integral part of x plus y. So let me write that. If r plus, so 0 less than or equal to r plus r dash less than 1, then integral part of x plus y is equal to integral part of x plus integral part of y. And if 1 less than or equal to r plus r dash less than 2, integral part of x plus y is equal to integral part of x plus integral part of y plus 1. Okay. So, integral part of x plus y has either this value or this value. Either it is x plus y, or that is integral part of x plus integral part of y, or integral part of x plus integral part of y plus 1. In any of these possibilities, you see that integral part of x plus y is less than or equal to both these. So we can say integral part of x plus integral part of y less than or equal to integral part of x plus y. Similarly, whether the value of this is this or this, we see that, see, both these are less than or equal to this quantity, integral part of x plus integral part of y plus 1. So in any of these cases, these required inequalities are satisfied. In any of these cases, the required inequalities hold. Okay. These are simple properties of the greatest integer function. We will now see some more properties, like integral part of minus x. It's equal to 0 if x is an integer, and it's equal to minus 1 otherwise. So to see this, if x is an integer, integral part of x is just x, and integral part of minus x, so minus x is also integer, so integral part of minus x is minus x, so x minus x, that is 0. So this is just easy to check. Okay, that, so let me just write this. If x is an integer, integral part of x plus integral part of minus x is equal to x minus x equal to 0. That's clear. If it is not an integer, if x is not an integer, right, x equal to integral part of x plus r, 0 less than r less than 1. Therefore, what is minus x? Minus of this, minus of r, which you can write as minus of x. Now, minus 1 plus 1 minus r. This 1 minus r is a positive quantity. 0 less than 1 minus r less than 1, because r is between 0 and 1, so 1 minus r also is between 0 and 1. Now you see that x is written in this form, minus x is written like this. If you add these, 0 equal to, this also gets cancelled. So you want actually integral part of x plus integral part of minus x. So let us write down these. What is integral part of minus x? Because this is between 0 and 1, it is minus of this minus 1. So if you take this on this side, integral part of x plus integral part of minus x is equal to minus 1. That proves this property. So what we have done is we have written x in this standard form, integral part plus this r. R is many times called fractional part. Now just write down minus x, write it in this form. From that you get the integral part of minus x, which is this, and then you get this result. So integral part of minus x is not just minus of integral part of x. That is what is made clear by this. Look at this property. This is also a very interesting property. Integral part of x, you first of all start with the real number x. Take its integral part. Divide it by positive integer m. Again take integral part. This is a very complicated thing and it looks simple. It is just integral part of x by m. Okay. Now you may think that this complicated looking thing is made simple here. On the contrary, in the applications you will see that to evaluate this we use this. It is exactly opposite. And you will see how certain calculations become simple because of this nice property of the greatest integer function. So let us prove this property. To prove, so this is property 6, x real number, m positive integer. Okay. To prove that integral part of x divided by m is equal to integral part of x by m. So the proof of this is like this. You write down x. So x is equal to integral part of x plus r, which is fractional part. 0 less than equal to r less than 1. So divide x by m and get some quotient and get some remainder. So write is equal to q times m plus r dash, where you are dividing by m So this remainder r dash is such that 0 less than equal to r dash less than m. R dash is less than m. Okay, r dash is an integer and it is less than m. Here this is a real number which is between 0 and 1. Okay, that is the difference between this r and r dash. R dash is an integer. So this is r real, r dash integer. This is just for our understanding. Now you can substitute this over here. Therefore, x is equal to q times m plus r dash plus r. Therefore, what is x by m? Equal to q plus r dash plus r by m. Now, 0 less than equal to r dash plus r, and it is strictly less than m. Because r dash is less than equal to m minus 1. It is an integer. Integer smaller than m means it is less than equal to m minus 1. Since r dash, so 0 less than equal to r dash less than equal to and 0 less than r less than 1. This is less than 1. So if you add these things, r dash plus r is strictly less than the sum of these two. Sum of these two is m. So r dash plus r less than m. Now, if r dash plus r is less than m, if you divide by m, you get this quantity which is less than 1. Therefore, 0 less than equal to r dash plus r by m, which is strictly less than 1. Now, if this quantity is strictly less than 1 and this is an integer, right? This q is an integer because q was obtained from this integral part of x divided by m, get the quotient as q and remainder as r dash. So q is an integer. Maybe you can write here q integer. It is the division algorithm that we have used. Now what is the integral part of x by m? X by m is integer plus this quantity which is between 0 and 1. So integral part of this must be q. So therefore we get integral part of x by m is equal to q. But what is q? You can see that q is the quotient when you divided integral part of x by m. So q is the integral part of x by m. Whenever you divide any integer by some positive integer like n, you get some quotient. That quotient is you can write the quotient as integral part of the given number by m. So we have got the result, and in this we have used, this is the result we have used. What did we use here? if, or directly you can see, divide this by m, what do you get? If you divide integral part of x by m, you get q plus r dash upon m. So integral part of x by m is equal to this quotient. So this is something which we require often. So if n equal to q times m plus r, where n is an integer and this is between 0 and m, then what is integral part of n by m? That's equal to this quotient. Okay, that quotient is the integral part. That is clear. So this is something which we use very often. Here we have used that. So we have got the result, integral part of x by m equal to integral part of x by m, where x is a real number and m is an integer, positive integer. So this is an interesting property. Now, given in the real number like this, there are two integers which are very close to it. In this case, 2 and 3 are close to this. Now, if you are interested in nearest number which is slightly larger, see, integral part is the nearest integer which is less than or equal to the given number. But you may be interested in this number which is also near to this, but closest to this on this side, right side, or it's a bigger equal number than the given number, and it is closest. So what can you express this number in terms of the greatest integer function? Okay, and that's what is done by this result, that minus of integral part of minus x is the least integer bigger equal x. Okay, it is closest from the right side. So let us how to get this. You can check in this also. This is your x. I want to get this. So what is minus x? Minus x is minus 2.4 in this case. Now take the integral part of minus x, which is minus 3. And take minus of this. That is 3. That is this number. Okay. So you can get this number in this fashion. So we will now prove this. So 7, let x equal to integral part of x plus r, 0 less than equal to r less than 1. Then if x is an integer, the least integer bigger equal x is x itself. If x is an integer, what is the least integer bigger equal x? That is x itself. Now what is the value of minus of integral part of minus x? The value of this is minus x is also an integer. So it is minus of minus x, and which is equal to x. And therefore this is the expected result, minus of integral part of minus x equal to x. In this case, which is the least integer bigger equal x. Bigger equal x. You get the required result. On the contrary, if x is not an integer, so if x is not an integer, what is, so let us write down minus x. In fact, integral part of minus x we know. So minus of integral part of minus x is equal to minus of, what is this integral part of minus x? We already have done in this property, that if x is not an integer, then this is minus of integral part of x minus 1. Integral part of minus x is equal to, what is this? Minus of integral part of minus x minus 1, which is integral part of x plus 1. Okay, I used 5 here. Otherwise you can do directly also, just calculate it. From this expression you calculate, write down minus x, which is minus of integral part of x minus of r, that is minus 1 plus 1 minus r. So you can calculate it directly or use that property 5. So you have got the answer, got the value of minus of integral part of minus x. It comes out to be this. But what is this number? Now you see that x is not an integer. So we have that this is the integer which is bigger than or equal to x, and it is the least integer bigger or equal x. Okay. So now integral part of x is strictly less than x because x is not an integer, as x is not an integer. Integral part of x is strictly less than x, and x is equal to what? Integral part of x plus r. This is 0 less than equal to r less than 1, and therefore this is less than or equal to integral part of x plus 1. In fact, it is less than integral part of x plus 1 because r is less than 1. So integral part of x less than x, and x is less than integral part of x plus 1. So what is the least integer bigger equal x? It must be this, because if you take the previous one, that is smaller than x. So this is the least. Therefore integral part of x plus 1 is the least integer bigger equal x, and that's what you wanted. Therefore minus of is the least integer bigger equal x. In both the cases, when x is an integer or x is not an integer, in both the cases we get this result. This is the proof of property 7. Now there are two other integers which are associated with the given real number x. We have this number x and we have the concept of nearest integer like 2.4. X is 2.4. What is the nearest integer to it? Now there are two numbers which are close from this side and this side. So this is less than actually 3 and this is bigger than 2. This is closest from the right, this is closest integer from the left. Out of which this number is the nearest integer. Okay. Sometimes nearest integer is on the right side, like if I take 2.6, then this is nearest. So nearest can be on the left side or right side. It can be itself like 2. This itself is an integer. So nearest is 2. So we have the concept of nearest integer. Now for this concept, you have one difficulty, like what is the nearest integer for 2.5? So here this is nearest, here this is nearest, here 2 itself is nearest. What about nearest integer for 2.5? Now there are two possibilities. Okay. So nearest integer function right now can have any of these two values, 2 and 3. Now you may be interested in a function like this. You would always take nearest integer. But when there is ambiguity, like this, when you have 2.5 and there are two possible answers, you take the larger answer. Okay? That is given to you. That your nearest integer function should be such that whenever there is doubt, like you have a number like integer plus 1/2, integer plus 0.5, that for that number you should take the larger one out of the two possibilities. This is your function. Now this function can you write in terms of the greatest integer function? And the answer to that is yes, it is given by this. Nearest is integral part of x plus 1/2, and this also satisfies the property that if two integers are equal near 8, equally near, it is the larger. If two integers are equally near to x, it is the larger. Okay. So let us prove this property. Actually, you can yourself try this. So we have to make various cases. So let x be a real number. Let n be the integer nearest to x and such that if x has two nearest integers, then n is the larger of the two. That is, if x equal to integer plus 1/2, okay, equal to m plus half, say integer plus half, then what is n? N equal to m plus 1, that is on the right side, m plus 1, larger of the two. This is the property of n. And then what is the value of capital N? So we have to prove that n equal to integral part of x plus half. So we make various possibilities. Write x equal to integral part of x plus r, 0 less than or equal to r less than 1. And we make various cases. If 0 less than r less than 1, nearest integer n is equal to integral part of x. Also, what is x plus half equal to integral part of x plus r plus half, and 0 less than r plus half less than 1, and therefore integral part of x plus half equal to integral part of x equal to n. That's what you want. In this case, these two match. N and integral part of x plus half match. Then take another case. If what is no, here I wanted to say 1/2. If 0 less than r less than 1/2, then so out of this I am making the first case 0 less than r less than 1/2. Now in this case 1/2, r is less than 1/2, therefore 1/2 plus 1/2 is less than 1, and that proves the result. Next thing is, if 1/2 less than r less than 1, then what happens? So what is the nearest integer in this case? Nearest integer is integral part of x plus 1. So n equal to, so then n equal to nearest integer x plus 1. Like the case 2.6, x is equal to 2.6, that is r is 0.6, which is bigger than 1/2. And okay, now what is x plus half, which is integral part of x plus r plus 1/2. Now this quantity is bigger than 1 plus 1 plus r minus 1/2. And this r minus 1/2 is bigger than 0, 0 less than r minus 1/2 less than 1. Therefore, the integral part of x plus half will be equal to integral part of x plus 1, and that is the nearest integer. That is the nearest integer. Now the third case, if r equal to 1/2, if r equal to 1/2, there are two possibilities. Nearest integers, there are two. One is integral part of x, another is integral part of x plus 1. Which one is larger? Larger one is integral part of x plus 1. So then n is equal to integral part of x plus 1. This is the larger of the two nearest integers. Now x is equal to integral part of x plus half in this case. Therefore, x plus half equal to integral part of half equal to integral part of x plus 1. Add 1/2 to both sides. What is the integral part of x plus half? But this is an integer. This is an integer. Therefore, it is itself x plus half. That's equal to n. Because in this case, the value of n is this. So in all the three cases, we get integral part of x plus half is the nearest integer to x satisfying the requirement. The requirement is that when there are two numbers equal, you take the larger. That's the requirement. It is satisfied. Now, suppose you want a function which satisfies that it is nearest on one hand, but when there are two nearest integers, you should take the smaller one. Like you want the value of the function at 2.5 as 2 and not 3. Suppose you want that. Then also you can give the formula, and that formula is minus of integral part of minus x plus 1 half. Okay. So that we can do similarly. At 9 is that minus of integral part of minus x plus half is the nearest integer to x, and if two integers are nearest to it, this takes the smaller value. This is the property 9, and proof is similar. Proof is similar. So I will not write down the proof of this. You can get it from the previous proof for property 8. So one more property I will write, that if n is an integer, n is a positive integer, and m is another, m is also a positive integer, you have this result that the quotient, if you divide n by m, right, n equal to m times q plus r, 0 q integer and 0 less than equal to r less than m. Then the quotient q is integral part of n by m. I think this is clear because you divide by m, integral part of n by m equal to q plus r by m, that r by m is less than 1, so we get the result. But another way of looking at this same statement is, suppose you are asked this question, how many multiples of m are there which are less than or equal to n? Okay. How many multiples of m are there? Like m, 2 times m, 3 times m, etc. What is the largest multiple of m which is less than or equal to n. So you see that this q, m times q is less than equal to n. But if you go beyond this, q plus 1 times n, that becomes larger. Okay. So how many multiples of m are there which are less than or equal to n? Okay, the question is this. Number of multiples means integer multiples of m that are less than or equal to n. What is the number of multiples of m? That number is q. There are q multiples of m which are less than or equal to is q, and it is given by integral part of m. So another way of looking at this thing is number of multiples. Integral part is used for this also. How many multiples of m are there which are less than or equal to n, given by integral part. Now I will give you an illustration. A simple example. Find integral part of divided by 125. Now this we can do, but I also want and also 1256 by 25 and 1256 by 5. I want all this. Okay. Now see how you can find out these things somewhat easily from this. This anyway I want to find out. You will see how this is useful in later problems. So what is 1256 by 5? This is 251. Okay. Now I want to divide this by 25. This 1256 I want to divide by 25 now for this, to get this. I can use this calculation to evaluate this. Instead of again dividing by 25. See, especially you will see that suppose instead of 5 I have taken a number like 13. Then this is 169 and so on. So I can use the previous calculation to get the next thing. How do I do this? So 1256 divided by 25, let me consider this as integral part of 1256 by 5 again by 5. Okay. Now this is your x. Integral part of x by m is equal to integral part of x by m. You can use the property. This is, consider it as integral part of x by m. And this you are replacing by a more complicated looking expression. This is simpler expression. This is looking complicated. But this is actually very helpful. Now see, what is this? Integral part of 1256 by 5 integral part. But this you have already calculated and the number has become smaller. Okay, number has become smaller because of the calculation. This is 251 divided by 5. And again you have to divide by 5 only. It is a small number. Okay. What is this? So this is 50. This we have calculated. Now from this we can calculate 1256 by 125 integral part, because this is integral part of 1256 divided by 25 divided by 5, integral part. Okay, this is integral part of x. X is this number. Integral part of x divided by 5, integral part. So what is this? This you have already calculated. This is 50 upon 5. This is 10. So this is how these rules can be used and the calculations can become simple. Now we will see how this integral part is used in getting some other information. So in the next lecture we shall see the Pauling-Nash formula. Okay.